Hello and welcome to this latest video within which we're going to be having a look through the model answers for the May 2023 paper for Unit 1. So this is part of the OCR GCSE Computer Science specification, and as I say is the Unit 1 paper for May 2023. We're going to do this as a walking talking mock, so my suggestion is you've got a blank version of the paper in front of you, you attempt each question and then continue with the video to see the answers that I would be giving. In each case, I'm giving an answer that will get full marks, but hopefully in a fairly short and sharp way. So I'm hoping that those answers are to the point and will get you those marks fairly quickly and without needing to go into too much detail in your 90-minute exam. So this is the content for Unit 1. Hopefully you've studied this in class. You've got 6 key topics: systems architecture, memory and storage, computer networks, network security, system storage, and then the impact of technology. And that will almost always be the essay question within Unit 1. So hopefully you've got your blank version of the paper in front of you. Let's get going. So question 1, and in fact a double page in the exam paper, starts off by looking at a range of different binary questions. We've got a tick box which says tick 1 to identify the statement about binary that is true. Binary digits can be the values 0, 1 and 2. Well, that's not correct. We know that binary can only be on or off and 1 and 0. The leftmost bit of a binary integer has the smallest value. That's not correct. So we know that when you start labeling binary numbers, you always go from right to left. That's the same with our numbers. If you look at the number 101, it's the right-hand digit that's got the smallest value. Binary is used because computers are made up of switches that can be only on or off. Now that one sounds like a winner. So the correct answer for number 1 is going to be that answer there. The CPU is made up of billions, millions of tiny little switches, and each switch can either be on or off. The final option was the smallest whole number that can be stored in 8 bits is the number 1. Well, that's not correct. With 8 bits, we can store from 0 to 255, so that would not be the answer for that one. We've then got a table where we're asked to do a range of different conversions. It's quite nice in that it's given us the 8-bit binary and the hexadecimal. But in the first one, we're asked to then calculate the denary. The same as we go on down the table, we're always given 2 of the values. So if you know how to convert from hex to denary, you're going to get the mark. Or if you know how to convert from binary to denary, again, you're going to get the mark. Now, that's a really important topic to practice because these come up every single year. There are separate videos on how to do these conversions, but the answers are going to be there. So 7 for our first box. If we look at our 8-bit binary, we've got the 1 is on, the 2 is on, and the 4 is on. If I add those up, that comes to 7. I then need to make 49, the denary number 49, or the hexadecimal number 31. So again, I'm thinking, how would I convert those? And the answer is 0011, 0001. I've got 102 in my third column, and then F4 for my final hexadecimal answer. And if you're struggling with any of those conversions, I suggest you pause the video at this point and then take a look back through the binary lesson. Page 2 continues on that similar theme. It's asking around some file sizes and looking for the smallest file size. It's asking you which then are the same, then some binary addition, and finally we're looking at some division and multiplication in terms of left and right shifts. So have a go at these questions now, and when you're ready for the answers, the first tick box for number 1 is going to be 200 megabytes. So we're checking between 2 million bytes, 2,300 kilobytes, and then 0.1 gigabytes. So you need to be thinking which of those is the biggest. And to do that, I'd be converting them all to the same value. So converting bytes to kilobytes and then to megabytes, and maybe converting the gigabytes down to megabytes. The next one says tick 2 boxes to identify the 2 file sizes that are equal to one another. Well, 4.5 million bytes is the same as 4.5 megabytes. Mega meaning million. So those are the two that are going to have the same value within that question. We're then asked around some binary addition. So we're asked to add two 8-bit binary numbers and show all of your working. That's really important. If you get the right answer, you'll only get 1 out of 2. You've got to show your working, particularly where you're carrying digits across. So we know that a 0 and a 0 makes a 0. A 0 and a 1 makes a 1. 2 1s, then we're going to carry a 1 and put a 0 in the current column. And 3 1s would be a 1 carried and a 1 in the current column. So you can see there, I've put my answer in the line for the answer, but I've carried those 1s up above. You'll see in this question I've got an overflow error. In my final column, I've added a 1, a 0 and a 1, a 0 with a 1 carried. You don't need that 9th bit. You'll get the mark whether you put the 9th bit or not. It does say add the 8-bit binary numbers, but it doesn't say whether it would like the answer as an 8-bit number or a 9-bit number with an overflow error. But that's going to be the answer for that one. We're then asked to identify the binary shift that's taken place on two binary numbers. And the answer there is a left shift by 3 places. You just need to compare the two numbers and think, right, what has happened? In which direction have they moved? And I can see that the second number has moved to the left 3 times from the number you're given in the question. We're then looking at a question around the internet. So a student is performing a range of actions on the internet using their computer. A range of protocols are used, and it's asking you to identify the protocol in each of the tasks that have been given. So requesting a view on a news page, so requesting the BBC style website page, ensuring a username and password has access to their bank account, downloading a text document, and then checking for emails in an inbox. There are a couple of sets of answers that you can have for this one, and they're available in the mark scheme. But HTTP, that's us viewing a normal web page. HTTPS, that's me looking at a secure website. FTP is my file transfer protocol, so if I'm downloading a text document, it's likely to be with FTP. And then for emails, we can look at IMAP or POP, both perfectly acceptable answers for there. Part 2 is a question that students tend to struggle with. So some protocols have layers. We'd normally discuss the TCP IP protocol as having 4 layers. You don't need to be able to name them, but we do need to be able to explain why that might be useful. Okay. Whenever this question comes up, we want to be thinking about the fact that each layer can be developed separately. So for example, when we moved from IP4 to IP6, that only required one of the layers to be updated. Second one, well, each layer can be updated without impacting the others. Okay, so they're fairly abstract layers. We can edit layer 1 and that shouldn't have a knock-on effect on layer 2 at all. So remember those two answers. This does tend to come up every couple of years. If I were betting, I'd say it probably won't therefore come up in the summer of 24, but might well come up in the summer 25 exam. Just memorize those two answers. It's that idea that we can develop each layer separately, maybe with a different team of people, but also the fact that an update to one layer won't impact the other layers. Our final question on this page then asks for one characteristic of a LAN, a local area network. How is a local area network different to a wide area network such as the internet? There are a couple of answers you could have here, but the big one is that a LAN doesn't require any third-party hardware, such as a phone line or a satellite or something like that, to connect to other computers. So a WAN is made up of third parties, so like BT phone lines, but a LAN doesn't require that. Again, this is a question where students have tended to drop marks historically, but a good answer there to get is that we don't need any third-party hardware. We're then asked to describe the benefits of a student changing their home LAN to include wireless connections. Whenever we see a question like this, it says describe, I'm thinking, right, how many points do I need to make? It's a 4-mark question, so I need to make 2 points that I then describe. You get a mark for saying the point. You can move round, but you'll get a second mark for explaining why is that a benefit or describing the benefits that that might bring. Whenever I get questions like this, I'd be bullet pointing my answers. I'd make it really clear to the examiner, I've got 2 points here, and within each one, I'm naming the reason and I'm explaining why that might be a benefit. So, for example, in my first one, there'd be no trip hazards. Yeah, I'm getting my tick there for what? Why is that the case? Well, due to there being no wires run around the house. So we might have historically run an Ethernet cable up the stairs, and that might be then a trip hazard. For my second one, devices can be moved around. Tick, I'm getting my mark for what. Why is that a benefit? Well, that means a user can work from any room. This is a typical question where students limit their marks due to exam technique not being right. They know the answer, where you can move around and there's no wires, but you're not getting 4 marks. You're limiting yourself to only 2 marks if you put those sorts of answers. So have a think when you see those describe questions for either 4 or 6 marks. That means they want us to be making 2 or 3 points that we describe why that's a benefit or why it's the case. The second question, though, is the opposite of that. It says state 2 drawbacks, and it's only 2 marks. So all I need to do there is make my point. I don't need to say why, I just need the what. What are the drawbacks? Well, wireless can have interference, and it can also be less secure. If that were a 4-mark question, I'd need to be saying can have interference, and this means that your internet might cut out during a meeting. Or less secure, and that means that your internet banking might be hacked. But it's not. It's a 2-mark question with the key command word state. Okay, so within that, I just need to make my 2 points. I've then got a nice question that's got some fill in the blanks, but is slightly mean and I'm given lots of options to pick for each blank. A character set stores all of the characters that a computer can represent. Each character is given a unique binary code. Lowercase and uppercase characters are given different binary codes. One example of a character set is ASCII. Now this is a slightly controversial question because ASCII can be 7 or 8 bits. Now officially ASCII is 7 bits and extended ASCII is 8. However, the exam board have said they're always going to consider ASCII to be 8 bits, and they've also not given you 7 as an option. So a character set in ASCII uses 8 bits for each character. It tells you that an F is then a 70, and all you need to do is count up. So if an F is 70, what letter would be, what would L be? And the answer to that is 76, and it is 6 higher than F. It then goes on to talk around some binary images, and we're told that 0000 is red, 0010 is green, and so on for blue and purple. We're going to need that on the next page. Firstly, though, we're asked what's meant by metadata, and metadata is that idea of data about the file, and data is the key word there. Don't use the word information, don't use the word stuff, it's data about the file. Now again, if that were a 2-mark question, I'd need to give an example. Data about the file such as the resolution or such as the color depth. In a Word document, metadata would be things like whether it was ASCII or Unicode, which character set. But it's a 1-mark question, so data about the file will get us our mark. We're then asked to look at a binary image. We're told that the binary image is 3 pixels wide and 4 pixels high. We're also told that the color depth is 4. I'm asked to then think what color is each pixel going to be. You'll see in my answer that I've drawn little dividers to break it up into 4 bits. If I look on the previous page, I know that 0000 was red, and I've therefore got 2 reds in a row. I also know that 0110 was purple, so I'd write that down. I then need to start a new line, and you're expected to work out that the computer would know there to start a new line. Now in this question, you're given a mark for red, purple being correct, the first line, and then you're given another mark for the remainder being correct. Okay, and I expect this is either a question where you've got full marks or no marks at all because you messed up how those images are stored as binary. The color depth used is 4. This means that 4 bits are used for each pixel. You're asked then to work out what's the maximum amount of colors. And there's 2 ways of doing this. You could write down all the combinations of 0s and 1s if we used 4 bits. But the real answer is you do 2 to the power of 4. So the color depth is 4, so that's to the power of 2 times 2 times 2 times 2. So the answer there is 16. You've got 16 different combinations that you can work out. If the color depth were 5, it would be 32. And if the color depth was 6, it would be 64. We just keep doubling that number. Finally, state 2 effects that increasing the color depth will have on the file. Again, whenever we get this sort of question, there are 2 obvious answers. It's going to improve the quality or improve the range of colors, but the file size is going to increase. And that will be the same if they were to ask you about sound files. The quality of the sound file increases if the sample rate goes up, but the file size is going to increase as well. So whenever we get that question around what's the impact of this, that's going to be your answer. If it's gone up, the quality increases. If it's gone down, the quality decreases. And the same for file size. We're then asked a question around compression and the idea that a student wants to compress a text file and then an image file. Now again, this is one where students didn't really tend to get 6 marks, and they probably should have. If we're compressing a text file, it's got to be lossless because we can't afford to get rid of any of the data. If I took this PowerPoint and deleted half the letters, it wouldn't make sense. Or if I said that this PowerPoint can't have any words with the letters A, C or E in it, it just wouldn't work. The justification, we need all of the data as no words or letters can be removed. That's going to be my first mark. Then I need to say that why, because it's in effect a 2-mark question. You're getting a mark for lossless and then 2 marks for your justification. If they were removed, the document would not make sense. Again, think about your exam technique within that answer. We're then asked the same question but about image files. Well, in image files, lossy compression is fine because that will remove certain pixels or certain colors, but we should be able to do that in a way that is not overly noticeable to the human eye. Okay, and that means we can reduce the file size down even further. This is another prime question where you need to think about your exam technique. Were you able to get the most marks given your knowledge? Many of you weren't. You put lossless and you might have been correct, but your justification really wasn't there. So we then move on to a question from the middle part of the course, looking at networks, network security and threats to customer data. We're asked to tick a box for spyware, brute force attacks, data inception and SQL injection to identify the sort of prevention method that we might be able to put in place. Now there are more than one answers that they will accept, but these are the ones you must have. Okay, so you'll only get the mark if you have these 4. There are some extra ones you can tick as well. So for spyware, for example, firewall is an acceptable answer, but anti-malware is the main answer they're looking for. So you need to be thinking around all of the different threats that are part of the course, and you knowing which of those prevention methods are most effective for each threat given. We're then asked to name one more and to describe, thinking about our exam technique, what and why, that's not given in question 4A. So I've gone for phishing. For the what, I've said fake emails sent to trick a user. Why? Well, it's to trick them into clicking a link or giving away personal information. So those sorts of emails that we get that we know are junk, but ask you, hey, click here to reset this password because your account's at risk. There are a number of different threats that you could have here, but phishing tends to be one that comes up quite often. So I think phishing is definitely one that you want to be aware of. We're then asked about an artist who's got a computer that they use to create images. Their computer has both hardware and software. The hardware includes primary and secondary storage. Can you explain why we need both? Now, this is another question that students tend to either get full marks on or no marks at all. It's that idea that the ROM stores the startup instructions while the RAM stores the currently running instructions, the currently running programs. And you need both of those then, would get you a mark each, and you need both if we're going to be getting full marks there. We're asked to give an example of secondary storage devices that the artist's computer might have, and one example of the things they might store. I think this is a really mean question because the mark scheme specifically says they're looking for a type of secondary storage, not a category. So if you said magnetic, you wouldn't get the mark. That's the opposite to the way they usually ask this question. They usually don't want you to say hard drive, and they do want magnetic. But for this, it's asking for one example of secondary storage, so a specific type. So I've gone for hard disk. And the sort of thing that might store for the artist is the images that they've created or completed. Like I say, another example of a question where you're probably going to get full marks or no marks at all. We need to know optical, magnetic, and solid state as our 3 types of storage device. And within those, can you think of some examples? Finally, we're given some statements to correct, and we're told that some of these are false, and can we correct the statements that are incorrect? So for this one, we're looking at virtual memory, and it says a section of the primary storage is partitioned. Well, that's not correct. It's a section of the secondary storage. Data from ROM is transferred. Well, it's not. ROMs are read-only memory, our startup instructions. That's always going to be in the ROM. So it's data from RAM. The third one is correct. And our final question is that idea that it's transferred back to the RAM, not back to the secondary storage when it's needed. So if we switch between Spotify, Chrome, and Photoshop, when I switch to Chrome, the Chrome instructions move back to the RAM from the virtual memory. We're then asked around some operating systems and utility software questions. We're asked to state the need for utility software. This is one you just need to memorize. It's always going to be a 1-mark answer, and it performs housekeeping actions. Those actions to keep the computer running smoothly. Okay, just remember that as the answer. Performs housekeeping actions. Next, the artist uploads images to a website. This is a client-server relationship. Identify the computer acting as the client and justify your choice. This is another question where we're getting 3 marks. 1 for the choice, but 2 marks for the justification. It's another question where students didn't do particularly well. So the client in this relationship is the artist computer. What's 2 reasons for that? Well, it sends the request to the server to upload the file. I'm being really clear that I'm making 2 separate points there. That's the computer that sends the request, and the request is, hey, can you please upload this file? Our server is then the web server. That's really important. You've got to be calling that a web server. The mark scheme's quite explicit around that. The web server receives the request, and it stores the files. It's the computer that holds the files in the longer term. A bit of a mean question there, and that's one to certainly make sure you're aware of as you approach your real exams next summer. We're then asked around some legislation, and we're asked around open source versus proprietary software licenses. I'm asked to describe 2 benefits to the artist and programmer of releasing software as proprietary. 2 benefits for 4 marks. I'm coming back to that. What's the benefit and why is that a benefit, or how is it a benefit? So for my first one, the authors can earn money. Lots of you will have written that, but did you get the second mark? By selling the game for a fee. How is the earning money going to occur? We can't sell open source software for a fee. We can, though, sell proprietary software for a fee. What's the other benefit? Well, it means nobody else can see the code, and that means it can't be copied or changed particularly easily. Okay, so again, what's the benefit? Nobody else can take my code. Why is that a benefit? Well, it means they can't change my code to put maybe malicious messages within it. However, I'm then asked from the other side, describe one benefit to the user of releasing the software as open source, again for 2 marks. Well, open source software means that anyone can edit the code, and that means that bug fixes or improvements or new features are likely to come out more regularly because more people are contributing to the code. So the answer for that one is users can edit the code, and that can help add new features more quickly. We're then on to the essay question. You'll always have an essay question in Unit 1, and it's pretty much always around the topic of things like ethics, privacy, legal, moral, or environmental issues. In this one, a new shopping centre is going to be opening with a new CCTV system, and that's going to record their customers, identify movements, and record individuals throughout the shopping centre. Describe the positive and negative impacts. We're looking for 8 marks here. To get 8 marks, you need to give a balanced and well-reasoned argument that draws in a range of different ideas around ethical, privacy, and legal issues. Now, I'm not going to write the whole essay for you. What I am going to do is give you some suggestions of the sorts of things you might discuss. What you would also do is make sure you had a paragraph about ethics, a paragraph about privacy, and a paragraph about legal. Ideally, balancing the positive and negatives within each one. So here's my essay plan that you might want to think about. Legal, well, the Data Protection Act means customers must be informed. So it's a positive, we'd need to tell the customers, we'd need to put up signs that said, hey, CCTV is in use. And it would also be able to be used to identify criminals, and that's undoubtedly a positive from the legal aspect. A negative, well, the company, the shopping centre, could be fined if they don't follow the Data Protection Act. So if they didn't put up signs, that could mean they end up getting fined, which is certainly a negative for them. Ethical, well, the staff might feel safer. The staff might like the fact that they're recorded at work, and if anyone tried to steal from the shop, it would all be caught on camera. It's also the fact that the customers have a choice of whether to shop there. If they don't like the CCTV being used, they could go and shop in another shopping centre. What about our negatives though? Well, some customers might not like it or feel safe. They might not like the fact there's cameras everywhere. And some customers might not be aware. So we might put up signs, but not everyone will see them. Not everyone will read them. Those sorts of things that just blend into the background. And what about privacy? Well, users have chosen to go there. So, those customers chose to go to that shopping centre. But in terms of the negatives, lots of people might see that as an invasion of privacy, and the recordings could be hacked. What if we had a camera somewhere near a changing room? Could that get, an angle that's not appropriate, or even be hacked so that somebody could hack into that camera and keep track of where certain people were? What you'd need to do is take those points and form those into an essay to get 8 marks out of 8. The essay question continues onto the final page, so you've got plenty of space for that one. And our final question then looks at embedded systems. It wants an example of an embedded system within a car, along with an explanation of why. Most people here got the mark for the example, but didn't get the mark for the explanation. I've gone with sat-nav. I think a sat-nav is an example of an embedded system, but there are loads. Parking sensors, entertainment system, automatic windscreen wipers. What all of those have in common, though, is that those embedded systems have got a dedicated CPU with limited functions. I can't take my sat-nav and install Microsoft Word. I can't install Scratch. It's only designed to do very simple tasks, the tasks it was designed for in the factory. So an embedded system is a dedicated CPU within a larger device. You don't get this in this one a mark for that idea of a larger device because they're saying they told you that in the question, in that they said that can be found in a car. So that was self-explanatory. But it's that dedicated CPU with limited functionality for our final 3 marks. I hope that's been a useful run through of the May-June 2023 paper. Your teachers will be able to access that through OCR Interchange, and I really do suggest having a number of tries through a blank version of this paper if there were questions there that you struggled with. As always, if you do have any questions, please post those into the comments section below or onto Google Classroom. Thank you very much.